Our third topic is called partial derivatives and extrema of the function of two variables. In this case, our function z is equal to pi multiplied by x1 squared multiplied by x2, and means the volume of cylinder with base radius of x1 and cylinder height means x2. We see that this function depends on two variables, x1 and x2. This is example of the function of two variables. Our x1 and x2 are called independent variables, and z is called a dependent variable. So, if we have to find a definition area of such a function, square root of 1 minus x1 squared minus x2 squared. What does it mean? We know that expression under a square root should be non-negative. That's why we may say that this expression under square root should be non-negative. And when we carry both x1 squared and x2 squared to the right hand side, we may see that this inequality means a circle with a center at the beginning of coordinates and radius which is equal to 1. So the definition area of this function is a circle with a center at the beginning of coordinates and radius which is equal to 1. When we have to find definition area of such a function, z is equal to 1 divided by x1 multiplied by x2, we know that we cannot divide by 0. That's why x1 multiplied by x2 should be not equal to 0. It means that both of them should be not equal to zeros. And definition area of this function is the whole plane except coordinate axis OX1 and OX2. Such a function we call linear, such a function quadratic, and this is like Cobb-Douglas function. So we call neighborhood of a point such belonging to a set X, we call a circle containing a point MO. When we fix one of unknowns, our function becomes a function of one variable. How to draw a graph of such a function? Z is equal to x squared plus y squared minus 2 times y. To do this, we may transform our function to the kind z is equal to x squared plus y minus 1 squared minus 1. When y is equal to 0, we see that in this case z is equal to x squared is parabola. When x is equal to 0, we see that in this case z is equal to y minus 1 squared minus 1 is also parabola. When z is equal to 0, this is circle with a center at the point 0, 1 and radius 1. So this surface is called paraboloid, and it looks like this. When the level line of the function of two variables z is equal to f of x, y is called a set of points on the plane such that in all these points the function value is the same and equals to c, and we call such a number c a level. Here we may see level lines. How to find level lines of a function? Z is equal to x squared plus y squared minus 2 times y. We may fix z is equal to c. So here instead of z we may write c. And we see that we may rewrite this equation such a way in such a way. It means that here uh, we have a circle with a center at the point O1 and radius which is equal to square root of c plus 1. So here we may see our level lines. So how to find limit of a function of two variables? Here this expression means that limit when x tends to xo, y tends to yo of f of xy is equal to a. And how to find, for example, such a limit of a function which is equal to natural logarithm divided by square root of something. Here, to calculate such a limit, we may denote by rho the whole expression x square root of x squared plus y squared. Then rewrite this limit as limit when rho tends to 0, because we may replace both x tends to 0 and y tends to 0 by rho tends to 0 of natural logarithm of 1 minus rho squared divided by rho. So here when we substitute rho is equal to 0, we see that natural logarithm of 1 is equal to 0. And here also divided by 0. 0 by 0, it's uncertainty, and we may solve it using L'Hopital's rule. We may find a derivative, separately derivative of numerator and denominator, and it's equal to 0. So we may calculate such limits such a way.